Hello everyone, welcome to Maths Bridge. Let's learn GenAI. GenAI means Generative AI, which is subset of your AI deep learning. Folks, please do visit us at our YouTube channel Maths Bridge. I think you are already subscribed to the channel. If you have not, please do subscribe the channel and then support us. Thank you and then happy learning. Here is our today's learning agenda. Before getting into the topic, the first thing that I have to ask myself that what is GenAI means, what it does, why do you need to learn? So before getting into these questions answered, I think we all know that one of the popular buzzword is known as AI. AI means artificial intelligence. Subsequently, we also looked at ML, right? AI, ML, artificial intelligence, machine learning are the popular buzzwords that industry is already adopting to implement solutions. There are several use cases which they are implementing. You might know few, but you can explore a lot more than what you thought so. But AI is one of the rapidly growing field within which now we are entering into a concept called a GenAI. GenAI means a generative AI. In all the domains that you know, for instance, life science, healthcare, industrial automation, right? If you look at and so many things anyway. So if you look at all the domains, every industry is now adopting AI/ML/GenAI type of solutions because we have the plenty of use cases, right? And industry is now adopting them to create a solutions to give a different customer experiences, right? So one of the the important topic that people are telling, using GenAI seamlessly you can improve the productivity of your learning or making a product or work culture, fast way of doing things, and then so many. So learning a GenAI is not an option now. It is a must-have skills for an individual should have in their skill set. So is it not enough for you to actually get motivated to learn, explore more on GenAI? Yes, the answer of course. We should be prepared for knowing better and improve the better skills in GenAI. Generative AI. This is extensions to AI. AI means artificial intelligence. So generative AI also called as a GenAI. GenAI is a new domain in AI, right? This is how you can understand things. So generative AI, why do we need this one? Generative AI is a type of AI that can generate a data, new data, like text, images, audio and music, software code generation, video generation, synthetic data generation, right? So how it does? Still it is a part of AI, right? So it does this by learning the structures and patterns of existing data, then generating a new data, new content with a similar characteristics of given input. When I say input, we might need to touch upon a prompt engineering. Okay, for now let's consider this as an input. For a given input, input data, it understand that structures and patterns of a given data from which it generates a new content, which can be a text generation, image generation, audio or music generation, code generation, video generation, and synthetic data generation. So you can now imagine how many use cases that you can build having this extra capability that the GenAI providing us. You agree? Beautiful. Before getting into a deep dive of a generative AI, let's recap of basic fundamental concept that we have learned so far. First thing that we have to see is like AI. AI means artificial intelligence. What this means, intelligence plus system is called AI, meaning you are giving a intelligence to the system to make system is AI. The machine is act like a AI, right? Artificial intelligence is a branch of computer science and engineering that helps a machine to think, able to make decisions and solve the complex problems as we humans do with our intelligence, right? That's called as AI. AI is not a future, AI is now happening. AI is already reshaping the future. Machine learning. Machine learning is a subset of artificial intelligence that focuses on developing an algorithms and statistical models that enables a computer to perform a specific task without explicit instructions. Instead, these systems learn and improve from their experience, isn't it? That's called a machine learning. Machine learning is a part of your a subfield of artificial intelligence. That is how you could think, right? This you have several things that you can explore further, but I'm not getting into the detail in this context. Now we know the AI and ML. So AI means artificial intelligence, ML means machine learning. You can rephrase it. AI is a kind of a discipline, a bigger one. ML is part of AI, a subfield. If you look at this diagram, AI, ML, and deep learning. So deep learning is again a subfield of ML. It is a new domain altogether. You can think that way, right? So what is this deep learning meaning? Deep learning models based on neural networks with a representation learning. The field takes inspiration from biological neuroscience and is centered around stacking artificial neurons into layers and training them to process data without human intervention. You could think so multi layers, there is inner layer, there are outer layers. Okay, so all the artificial neural networks, ANN, basically gives you like a lot of other important information which we can see in subsequent sessions. In a nutshell, AI enables machine to mimic human behavior through an algorithm. ML, machine learning, is an AI algorithm which allows system to learn from data. Deep learning is a subset of machine learning methods based on ANN, artificial neural networks with representation learning. Right? This is a simple way that you can remember what is a definition or a difference between a AI, ML, deep learning, for instance. Based on type of data that you are providing, we have a different types of machine learning. All right. So supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning are types of machine learning based on type of data that is given, right? So if you could recall, machine learning is a subset of AI that focuses on development of an algorithm that can learn, make prediction and decision based on the data. So let's look at now each one, what it means to us with respect to ML. Supervised learning. This is one type of ML, machine learning, right? So how the models is being built in supervised learning, assuming that you have a newly born baby, how would a newly born baby can understand the things that around us, right? Let's say you show the apple, how it would how a baby would know that this is an apple, right? Because one case you are talking about a picture, other case you are actually annotating, right? You have to teach model by saying, by seeing, right? You show the the thing and you annotate saying this name, then what happens? The model is now, learn by our supervision. That's called a teacher teaching a lesson to a kid, isn't it? So now you have it. Next time when you try test by showing a different type of apple, maybe a shape or color, whatever it is, now the model can think, yes, I know, I have seen this is apple, isn't it? So that means like the output that what you wanted to predict is also known to us, right? That is how I think the model is being built. So labels are output variables that the model aims to predict. So in supervised learning, these labels are providing in training data, right? Supervised learning, a machine learning involves a training the model on a label data where the correct output is known. So correct output is known, and then you learn first, and then from there you started predicting next time when we see the similar kind of objects, things, right? What I can call it as a label data. What is mean by unsupervised learning? Unsupervised learning is a part of your machine learning, right? Based on the data that you are giving. Assuming that this sort of the data that is given, but I don't know like what is the name of this data. So there is no label information associated with this data. Then how the model is going to build? Given unlabeled data is analyzed by the model and categorized by a computer model based on similarities that it found. What that means is it will actually try to look at the complete data, and then based out the similarities it will categorically divide the data. You mean to say like a clustering the data, right? So based on similarities that it sees, all the data can be clustered. So if in this instance, if I can see this input data is now clustered into 3 groups based out of their similarities. This type of learning is called as a unsupervised learning. Algorithm is left to discover patterns and relationships within the data on its own to cluster data that makes sense for us, right? Where we don't have a label data. Output is not known to us. Only based out of the similarities or differences, you can now cluster the data, group the data in this unsupervised learning. You get that one? Now we know that like supervised learning and unsupervised learning concepts at high level. Let's recap of what is meant by reinforcement learning, which is a part of types of machine learning, right? Reinforcement learning is one of the learning technique in which we reward an algorithm with feedback so that it can learn from it and enhance its performance. So what that means is you can assume that you are training the your dog by throwing some kind of a stick or ball to a distance and asking it to actually collect, right? So what it do, probably it won't listen at first go, but what you are going to motivate her is that, okay, if you can go and get it, I will give a biscuit. You reward with the work that it is going to do, right? So now what happens is like, okay, if I can do this job, probably I will get a biscuit. Maybe you will keep adding, give a like 2 more extra next time when it does. So this is how we work in reinforcement learning. That means this is absolutely a trail and error through learning, but this basically helps you to improve the performance of the algorithm, right? This is basic idea of reinforcement learning. The goal is achieve optimal outcome from the unseen data. Based on type of task, we can classify machine learning into discriminative, generative. Let's say for instance, in the context of NLP, natural language processing, these models focus on classifying or predicting of a input text, right? This is what mean by discriminative. Whereas the generative models In the context of NLP, if you look at these models focus on anticipating and predicting next most likely to come, means it generates new content. Do you see? In discriminative, you see only a classifying or predicting, whereas a generative, you are generating a new content. So based on type of task, now we have a different, the concept in machine learning, types of machine learning based on type of task that it does. Now let's get into generative AI. Generative AI is known as a GenAI, refers to a subset of AI that are capable of generating new data. What sort of the data? Text, images, audio, video, synthetic data based on patterns and knowledge learned from existing data, right? These models uses techniques like a deep learning, NLP, neural networks to produce the content that appears as if it were created by the humans. So mostly we're going to touch upon LLM, SLM, RAG in the context of NLP. LLM means large language models. SLM means small language models. RAG means retrieved augmented generation. Let me recap one more concept called a foundation model. What that means? A pre-trained model on which other specific models are built is known as a foundation models. That's beautiful, right? Now look at one by one. What is meant by LLM? LLM is like a generative AI model that trained on a massive data set that are good understanding of generation of a human, like a text based on input, right? So now look at the SLM. SLM is based on LLM but greatly reduced its size. So an SLM retains much of functionality of LLM but with far less complexity and computing resource demand. It is used for a specific use case. So you can build like the very complex large use cases using LLM, but special cases can be handled using SLMs, where we don't require to have like so much of the computing resource demand also. The other concept is called like a RAG. RAG is a type of GenAI that has the information retrieval capability. It modifies the interactions with the LLM so that the model responds to the user queries with reference to a specified set of documents. Using this information in reference to information drawn from its own vast and static training data. So these are the few concepts which are very thin layer of difference, but covers very vast use cases using GenAI. You got to appreciate, while learning GenAI, because you end up seeing like a, very vast, use cases in various domains. That is a exciting topic for all of us, and then keep us motivated to learn, do deep dive exploration in GenAI. So if you recap, using GenAI, you can generate a new data that is like a text generation, image generation, audio and music generation, code generation, video generation, synthetic data generation. All right. On short note, text generation. You might heard ChatGPT, generative pre-trained transformer, right? That's called GPT means. So ChatGPT developed by the OpenAI uses text generation to generate a human-like response with prompt engineering. The keywords you can take away, you should be familiarized with prompt engineering. You can start using like a ChatGPT, then you'll understand how it works. This is being developed by OpenAI. It basically uses for text generation, right? It generates human-like response, right? So internally, if you look at, Markov chains, recurrent neural networks, RNN, and transformers are being used in it. There are many applications, but I listed a few, like this particularly used in text generation use case, right? Chatbots, content creation, writing articles, language translation, and summarization. These are the few use cases which you can remember for now, but you can still explore more. You started appreciating like how text generation using GenAI can be built and implemented in various domains in the context of business, what I meant to say. Now let's look at image generation using deep learning algorithms such as a Waze, GANs, stable diffusion to create a new image, usually similarly to a real world images is what it is going to generate. Image generation applications, Midjourney, DALL-E are the image generating applications. You can explore it. More exciting to see what is happening with this GenAI for image generation use cases. Similarly, music and audio generation, composing music or synthesizing voice are the basic the use cases for it. The applications are JukeDeck, OpenAI's MuseNet. You can still explore to get more in detail. Coming to code generation, right? You are a software developer. If so, that you need to learn things faster. So this is one of the best example. Using GenAI, you can learn things faster. The tools like a GitHub Copilot use AI to assist developers by generating code snippets based on comments or code context that is given. That's more exciting. Now let's look at a video generation, video audio generatives. GANs and video diffusion to generate new videos by predicting frames based on previous frames. Sequence. Remember the previous and then predict the next frame. Applications, right? Deep brain, Synthesia, producing animations, deep fakes, video summaries, right? So I just captured as a like a short note so that you can refer to create a snapshot of what are all things, what are the jargons that you end up hearing most frequently, isn't it? Model architecture selection in GenAI. We looked at actually at high level neural networks. These models consist of like layers of neurons where each layer extract the features or patterns from the data. CNN, convolutional neural networks. So this is designed for image generation, video, image processing, isn't it? So CNN uses generator and discriminators. Generators for creating a new content. Discriminator basically just comparing new content with like an input to see whether generator generated image is like a fake or real. That's all. It has the internal layers through this process. Convolution layer, polling layer, fully connected layer. That's called a CNN concept at high level. So similar to the CNN, we have like a VAs, variational autoencoders. So this is also used for generating a new data, like image generation, but uses a different architecture. Here, encoding and decoding architecture is what, right, Waze uses. Now let's look at RNN, recurrent neural networks. This is designed for processing a sequential data like a NLP, speech, music, time series. You can think through here also. We have layers in RNN, recurrent neural networks, input layer, recurrent layer, output layer. There is a 3-layer concept like a CNN. So remembering a previous element to predict the next element. That's what RNN does. Now let's look at a GAN. GAN is a generative adversarial networks. It is one type of a deep learning, right? Isn't it? For generating new data, image, video, and audio. It uses two neural networks. That's called a generator and a discriminator. Right. So generator to generate or create a new data, for instance, a fake images. Discriminator is trying to find whether the created image is real or fake. Right. This are kind of model architecture. You are just to pick based on use case which one that you needed. That's an idea. So transformers. It is one of the neural network architecture widely used in NLP. Translation, text classification, question answering. These are the typical tasks that you can see in transformers, right? It is used in GPT for the text context, chat GPT, other way. Okay, so I think mostly I covered it, but we can get into more in detail. Each one has its own, the deep dive concept, which we can, discuss in subsequent sessions. But for now, you can just understand what are the models that are available, what for those we use in GenAI context. Let's now recap. Computer science is a bigger part, right? Computer science is adapted artificial intelligence, right? So machine learning is a subset of AI. Machine learning is driven to develop a deep learning. Deep learning is driven to generate a GenAI, right? GenAI means creating a new content, generating new data. Within generative AI, we have a LLM, SLM, and RAG. On the contextual view, we have shown as a LLM, large language models. There are other use cases, right, that we can discuss. GPT, basically a transformer, which is a part of your LLM. Chat GPT is the best simple, well-known example where we can, mostly see as a generative AI application. I hope this is clear, isn't it? That's beautiful. GPT means generative pre-trained transformer. Using generative AI, we have a plenty of use cases in various domains. For instance, healthcare domain, industrial automation, right, and so on. So if you can look at a few, which I have seen, most of our enterprise companies actually doing things. If you could actually, recall the few of the activities that is being done in the industry, like to improve the productivity, improve customer experience, improve process automation, content creation, question answering, summarization, classification, chatbot performance improvement, software coding, automated research and reporting, smart document processing, the product design optimization, personalized recommendations, health assistance, personalized medicine, supply chain optimization, product descriptions, data augmentation, real-time equipment diagnosis, AI-powered maintenance assistance, optimize subscriber experience, media intelligence, and many more. So this basically keeps us engaged to let you do little more deep dive and then started building your competency using GenAI. I hope this all helps creating like some kind of a baseline context and then getting into GenAI tunnel to explore more on how you will be a part of GenAI, be a competent within the generative AI skill. Good luck. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Happy learning. Thank you. Stay tuned to upcoming sessions.